So feel free to ask question as a online or on the Slack channel, and we will try to answer. So you can ask as a question from today or for today's talk, or if you have question related to the previous talk last week.
Okay, hello everyone. Andy, are you there as well? Well, I'll start. We have quite a lot of questions from today. Thank you, everybody. I will just offer a little rewind. So we started a poll earlier of which MR vendor you're primarily using. And as you've seen, we have a lot of Siemens integration, and that's been the predominant response. And we actually have a sort of a tie-off in second place with GE, Philips, and Brooker. There are a couple of others. I'll just want to trace up. So if you did write other, if you could just respond to the thread of which vendor you're using, it'll be good for us to get a picture of what people are using, and particularly if you're interested in working with Gadgetron. I guess there's a few specific questions, and I'll just follow up to what Valerie said. As there's a lot of sensitive Siemens information in Hui's talk, we'll probably end up putting that in a Siemens specific place, probably the IDEA board, just because there's, most of it is Siemens specific. But if you do have general questions about connecting, you can reach out to us, and we'll try our best to answer your questions. So we have a question of, can IceGadgetron be used together with PulseSec, the open source pulse sequence? I haven't used that particularly, but I don't know if anybody has.
I don't have experience on that.
Okay. That'll be something to add on. We have a nice question here that's started quite a discussion amongst the Gadgetron support team. It's from us and Java. It's like, can we use 2 recon chains for one data set in the XML? So I guess from the scanner, can we send the data twice to try out different reconstructions?
In current setup, we can't configure 2 chains at once, but you can, in the chain, you can have 2 chains in there. So you can have a split, then basically you can have 2 complete chains sitting in one Gadgetron XML. Then each one can run the complete scan. Then they will all send the image back to the scanner, all the Gadgetron client.
That's using the branch, the branching thing?
Either branching is the easiest. Basically, then each branch is a complete chain. They won't conflict each other.
And is there an example of a branching gadget? I think the Wrapup one uses that.
I think Christopher has, David, I think you guys had an example for branching specific, right?
Yes, there is a specific branching example, but you can also look at the real-time Wrapup. It's a little more involved, but it is a good example of how to use the branching feature.
Thank you. So the second part of his question is, so it's mentioned a specific Gadgetron chain, which is the ISAM-RMRD dump, which is a very useful feature when you're running on the scanner. You can just call this XML, and it will save the data stream to your reconstructor, wherever you're sending it to, in H5 format. So it's really useful when you're trying to debug problems, or just if you need to take your data offline. And the question was, does this dumping XML save the noise dependency information along with the data?
Yes, it will So if you configure IceGadgetron to process noise dependencies, you need to, so in that configurator section for a parameter, it has which chain will be used to process dependency. So I think in the Gadgetron repo, it has a dependency processing with storage. It has one chain for that. So if you're using that chain, or if you insert the ISMRD dump into the noise dependency processing, then every noise is received, it will dump first and then process. So you will have a set of noise data and imaging data. That's actually what we do every day. So we did one step further than this. We made a simple gadget chain which only has one gadget, which is ISMRD dump. And we insert that chain into after the read functor. So before everything, for some sites, for some collaboration sites, they agree to saving data for almost every protocol. So in this way, we basically save the entire scan. You can save the entire scan as MRD format. My practical experience is it has almost, we don't find any negative impact on the performance or stability, all kinds of things. So yeah, it's a very good way to save the data.
So it will save and reconstruct the data at the same time?
For the most setup we use, we only save the data. So you basically have a gadget chain has only dump gadget. So you won't send anything back, but the only functionality is to save the data.
Okay.
Yeah. No more.
So that would usually be used. I'm sorry. That would usually be used with the pass on data equals true, so that the data then carried on down the ICE chain.
That's correct.
Following that question is it recommended to compile Gadgetron under Windows for debugging with IceGadgetron?
No, I just mentioned you can. I do it quite often. In the Linux, you can compile Gadgetron in debug mode. Then you can also attach debugger using either Eclipse or Visual Studio Code. Then you configure IceGadgetron for the IDEA or for the scanner, sending data to that Linux box. Then we can do the basically same visual debug process.
Yeah. The beauty is when we send it with IceGadgetron, you can send it to whatever computer you want. So if you can send it to the data stream to a Linux computer, for example, running a debugger. It's obviously tidy to have it on one computer.
Yes. Also, you may have one setup of IDEA or scanner. You may have more than one people working on this, so they can share. I want to say that it has a wiki page to show how to use Eclipse to visually debug Gadgetron in Linux. So could be helpful. That's my most used way to debug Linux.
Question from Zhongchen. If you set pass on data in the configuration for the IceGadgetron XML, will we get both the image reconstructed by the Gadgetron and by the scanner itself?
In practice, we found passing on data in both ways sometimes can causing problems. So sometimes ICE may choke, depend on the timing the image received by the spice chain, so the chain after the Gadgetron. So my recommendation is you may have to test on your application. The most use case I had been used is to not pass the data down the chain. So that we have the most experience.
Question from Karina Iseva. Will the latest version of IceGadgetron work with a Siemens Prisma? And does it differ between versions? is it worth to update from time to time?
So the IceGadgetron works on the everything from the VE to NX. So IceGadgetron has two branches mainly, master branch for the everything VB, VB, VE, VC line. For the it has another branch called NX. It's for the newer NX, newer scanner. So you only need to compile Gadgetron in your specific software version.
Right. So it will be up to the user to compile it for their specific version, and it should work for generally all Siemens products. And I guess to answer the question, if it's worth to update, it depends on what Gadgetron you're sending it to, right? So like the newer features of Gadgetron 4 will be better served by a more up-to-date IceGadgetron. So if you want to do waveform sending and...
Yeah, that's if you're on this very new features, yes. For the very most basic stuff, so IceGadgetron stick to the MRD format, which is very stable. So in that sense, for majority of the use case, I think the Gadgetron, previous Gadgetron 3.17 or something, and the Gadgetron 4 should equally work. Which we actually had a deployment using both. So we had one scanner for some chain sending to a Gadgetron 4 Docker image, another chain sending to Gadgetron 3 Docker image. They both work pretty well.
Thank you.
And I think some of these more specific questions have been answered, but the question about where the Gadgetron server must be in terms of networking. The question is, I think it's just a username, is the Gadgetron server must be in the same network segment of the Mars.
Not quite. So if you use tunneling Gadgetron, you could have a gateway, for example, a tunnel. The bottom line is Mars has to be able to send data to Gadgetron server. So in this way, it can through different tunnels. You can even have more than one tunnel if the bandwidth is not a problem. So one setup we have is to have Gadgetron running on the Microsoft Cloud, which definitely not in the same network. Then what we do is we have a Linux box, which we let scanner sending data to this Linux box. This Linux box will relay the data to the offsite to the cloud. So if you have the relays, then you don't need to have Gadgetron server sitting in the same network.
Right, and I guess in terms of your actual cost, your relay computer does not need to be super spec'd in order for it to just pass that data on. The reason, if you noticed earlier, what we showed when we changed the IP on the local network to one address that's connected to the scanner, is it was predominantly from our lab's point of view. It's an interventional lab, so we're trying to do real-time imaging, and so we have a local switch where we connect the reconstructor to the scanner on, I think it's a gigabit connection. So it's to try to make that stream as fast as possible, rather than using or relying on hospital network speeds or on cloud transmission speeds. I will actually just, before we finish up on the last few questions, I just wanted to recap. There's a few questions earlier about the data used in the Python examples that Vinay was sharing. Vinay, you're going to update the Zenodo link at some point?
Yes. So what will happen is with Zenodo, you cannot modify or delete an existing data set for provenance purposes. So I will include that data in an additional link, and I'll post it in the general class forums. And a couple of the presenters indicated there are a couple more data sets that we could include. So I may wait till next week just to make sure we capture all missing data, but we'll get everything that we used up in an additional link.
Okay, thank you very much. But in the meantime, please, use your own data. That's what we're trying to really encourage in these workshops here, for you to get sort of handling in your data too. So, but hopefully.
Yes, I can say like the examples I used, they were converted GE data, but they're MRD. Like in the second sheet, those were MRD. So you can use any data that's been converted. Any 2D examples should work through that, and they should be flexible enough to be able to let people play with it. Thanks.
Thank you. I promised Kelvin that I was going to pick on him, and I think I'm going to choose that moment now. It's to talk. So Kelvin Chow works at Siemens. And he's been working a little bit in making IceGadgetron a little bit less hacky, I guess. So if you want to just say a few words, Kelvin.
Yeah, sure. I can also turn on my video here. Yeah, so we have been trying to make things a little less hacky. And we've been working on collaborating with the MAH group in making a whip out of IceGadgetron. So we're working on a slightly more generalized version of it. We call it Fire, and that supports Gadgetron as well as other things that support the MRD protocol. And I can answer any questions you might have about it.
Perfect, thank you. And I guess a personal question is Fire is going to be deployed on the Mars, or will it have the similar capabilities to connect to external machines?
So it's deployed in a similar way as IceGadgetron. So it supports both network connections through an SSH tunnel, as well as Mars chain root options.
Thanks. So, okay. A question from Wrapup again is, can Gadgetron distribute requests to different servers? How does Gadgetron manage load balancing, especially with heavy reconstruction workflows? And I think you have a perfect answer for this.
Yes, so we don't have Gadgetron by itself supporting the distributed computing, and it has some load balancing functionalities. Especially in the newer Gadgetron 4, it's the whole system. David and Christopher reworked everything. It's done beautifully. You can specify which data dimension you want to parallel. For example, one use case we had most experience is multi-slice cine imaging. Then we send the data for every slice to a different nodes. Before we sending the nodes, I think Gadgetron will query whether this node is busy. Then you can decide what you want to do. Either you can just send to it, or you can try to find another free nodes. Then every node will work on its recon job independently. Then after it's all done, it will be sending back to the main Gadgetron. Then all the image is sent back to the scanner. So in this way, it's in my opinion, it's truly achieved the distributed computing for the clinical imaging. But Gadgetron it's not Gadgetron's job to provide very complicated the load balancing. So if we want something more than that, then one thing we have been trying is using Kubernetes with Gadgetron Dockers. So the setup is truly Microsoft Azure Cloud with Kubernetes managed Gadgetron nodes. Then in this system, the Gadgetron nodes will be started if most computing nodes are busy. Then it will be gradually shut down if the nodes are free. In this way, we can. So we basically have two Gadgetron cloud computing setup, one in Europe, another in North America. Each have a number of hospitals, have a few protocols sending data to it. They will share all this computing resource. But in that way, the balancing is controlled by the cloud, so Microsoft Cloud's infrastructure, not exactly by Gadgetron. So it's different levels, in my opinion. So for the system and computing nodes level, we should better let those existing cloud infrastructure to control the computing loads. For the imaging level, for example, if we want to send every slice to a node, or if we want to let every image to be reckoned on a different computer, that level of control is done by Gadgetron. So yeah, that's the current status, and also a design decision, I believe, for Gadgetron how to handle distributed computing.
So perhaps I can add a little bit on this. In the default distribution mode, like Gadgetron will essentially round robin, like you decide how, but there is no, if you just have something generically distributed, there is no way for us to determine what node would be the best to send to. However, if your workload is distributed in such a way that it's one input, say a buffer, and one output, say an image array, then we can do something a little bit more clever. You enable that by using the pure distributed rather than the distributed node. And then we actually try and do timing on how fast a given node is completing a workload, and we try to balance that a little more cleverly.
Great, thanks, Hui and David. Have another good question from Karina. Is it possible to visualize plots, like custom plots, I guess similar to the AI registration that Hui showed us in his previous talk? So, sorry, I'll ask the question again. Is it possible to visualize some plots like quiver plots from registration or segmentation online on a scanner? What restrictions are there, and how can I pass them back into the reconstruction chain?
So simplest way, what we use most is just to save those plots as an image, then pass the image back to the scanner as all other images. So one use case we use a lot is, for example, we may pass the ECG waveform we received to plot back to the scanner, then they have a record. We may pass some processing, for example, we may run a cardiac mapping, then generate a AHA plot, then you can pass that pie chart back to the scanner, all in the image format. So another way I believe Oliver uses a lot is to, you can also configure Gadgetron to, in your external server, to plotting the image on the fly. So like real-time monitoring. That's also a very useful case. Yeah, Oliver.
And I think we saw that some examples where there was a Python gadget that's produced figures, and likewise we typically use MATLAB gadget to do visualization on the external Linux box, whilst also maybe doing reconstruction, or maybe only in order to visualize.
And so when you're doing those real-time visualizations, the data will just get saved to the MATLAB server. It doesn't get sent back to the scanner. Is that right, Oliver?
We have two different use cases. We have one where it is simply used for visualization for QA purposes, in our case, looking at subject motion and stability during fMRI runs. In that case, the reconstruction is actually on the scanner. So we're only using the Gadgetron emitter, and we're not actually sending data back to the injector. But also, if we have reconstruction being performed externally and then producing images back on the scanner, it's often useful also to have some, typically for us, diagnostic images appearing, just to check that the recon is doing sensible things. For example, we could display in an accelerated acquisition, we could pop up the reference image that's being used whilst only sending back the accelerated images. That would be a case. Can I ask a question on my own, different topic?
Of course.
It's actually Lars Kasper has been asked earlier on. So the question is, the general question is, how are dependent measurements, so for example, B0 shim maps, coil sensitivities, noise references. So Hui has shown us how IceGadgetron can mediate sending those data to Gadgetron. But also offline, is it possible to package those separate data sets into one MRD file, or should they be kept as separate MRD files with the current definition? And then how can reconstruction make use of the raw data or image data, which might be packaged in those, from several different MRD files, or effectively from a stream that contains first reference data and then acquisition data?
So the current scheme is, for example, if Gadgetron receive a noise dependency, it will try to save the noise pre-whitening matrix encoded by the patient ID, measurement ID. Patient, you mean, the ID is not the patient accession number, it's just a number to differentiate which scan it is. Then if we have an imaging scan, it will first check the protocol whether this scan has dependency. If it has, it will try to find, okay, whether the noise pre-whitening matrix has been stored in that particular dependent ID. If it is, it will try to read them in. So that's how it's handled for now. I think, yeah, go on.
I'm sorry. Is there a analogous method if an offline client is being used? So the Gadgetron RD client, for example, would there be a way to specify dependent measurements?
I don't know what you mean. It's solely determined by the MRD header. So if you really want to make the link between them, then you have to edit MRD header saying, okay, this scan has this dependency.
Yeah, Oliver, so there's a UID that's stored in the MRD header, and that refers to what the dependent measurements are. And then Gadgetron will look in its history to see if it's received it in the past. So when you're doing it offline with the client, you should send all of the dependent measurements first, and then Gadgetron will handle and parse those and save them locally, or save the analysis of it locally. And then when you run a later measurement that uses that dependent data, it'll see that it's seen it before and it'll use that information.
And is that mechanism quite general? So can it handle, for example, B0 maps, sensitivities, distortion maps, that sort of thing?
So style, yeah, go ahead. Maybe let me say one thing. So style sheet actually predefines 3 types of dependency. If you want other dependency, you can extend the style sheet. Then you have to add your own gadget to handle that particular dependency. You know, for example, the distortion map, which wasn't handled currently in the Gadgetron.
Yeah, I think I was going to say something similar, which is that the current pre-filled dependencies correspond to the dependent measurements in the Siemens world. But you can certainly add your own dependent measurements as well. So within the style sheet, you can define that you want your own dependent measurements and make it depend on something else, as long as you refer to the UID and have appropriate handling in your own gadget.
And it would be normal to have separate H5 files for the main measurement and the separate dependent measurements.
Yeah, I looked into that a little bit to see if we could bundle them into one, but the structure of the H5 files as we have them now in MRD, so the data are stored in a group called Dataset, right? So the Dataset has the XML header, it has the data itself, and then waveforms if they exist. And so I think many of our tools right now, they assume that it's just called Dataset, right? Like that would be the path, or that would be the group name. So you could put the dependent measurements in a separate group, but you'd have to update the format a little bit, and you'd have to update the tools to be able to read it from the other.
Thank you both. That's very good answers. Thank you.
I would like to add that like ISMRD doesn't really support storing process data except for images. So you can't really, I mean, you could store a B0 map as a complex image, but for other types of data, that's not possible. So typically you'd store the raw acquisitions that we use to produce that dependency rather than the process dependency itself.
Thank you.
Yeah, and I think there was like the other part of that is also like, would it be possible to save multiple raw data acquisitions in a single HDF5 file, kind of like how Siemens has multi-RAGE files? And I think that's what I was getting at. It's not really possible using the current setup, but it would be possible to extend it if that is something that is of interest.
I guess there's also the brute force method of just saving things locally to file and loading it, which will probably make our developers cry a little bit saying it out loud.
Yeah, that as we said before, Raj, that gets messy pretty quickly. But that's I think that's how we often do it. I think it certainly is worth having a discussion about how we could extend it in a more generalized fashion so that everyone can make use of such infrastructure instead of like everyone coming up with their own.
We touched a little bit about waveforms earlier, and Pierre-Andre Fissos has asked, what kind of waveforms are supported by ISMRD?
David, you know this.
Talked about this.
So I mean, they are fairly generic. So anything that fits inside anything that has a number of samples and a number of channels, you could put in a waveform. The main applications that it's been used for have been respiratory data and ECG data from the Siemens system. And we've had some requests for gradient waveforms where the current waveform system was not really general enough. So we are actually developing a waveform 2.0 to better support that use case. Like you can get the data into Gadgetron or ISMRD right now, but people were lacking sort of the metadata to use it effectively. So also if you have needs, like if you have a particular application where you need extra data into ISMRD, into Gadgetron, now is an excellent time to approach us.
David, are you speaking about the scope hardware to get the trajectory?
Oh,
we lost you.
Frozen. Yeah.
Could you repeat the question, Valerie?
When you say you're sending waveform, are you speaking about the scope?
Oh, you mean field scope.
Finding the trajectory. Yeah.
Sorry,
I'm fairly sure that Valerie is trying to get through his the scope field camera gradient measurement system.
Like that could be one application. So the current need that we're trying to fill is just getting the waveforms that you have that you are sending to to the MRI scanner, getting those to Gadgetron as well, so you can use them to compute trajectories. It could be used for a field camera as well, particularly if we know what's required to make that work. Like we're trying to make it general enough. But maybe Adrian, could you do you have anything?
I can chime in on behalf of Scope. I am a Scope user myself. I don't think there's anyone from Scope joining us today, but I know that they have been using MRD to transmit data from their products to their custom reconstruction. So they are using the MRD format, but I'm not sure what version they're using. So that is one of the capabilities, but I can't really comment on the state of it.
Do they use MRD to store like the scope specific data? Do they save any specific, do they use like the waveform data, or do they just use like regular raw data as we would?
I think they use the waveform data, but again, this is just my knowledge of what I've heard, being one of their customers. So I think it would be better to get information directly from them.
So I think I would really second David's comment of if you have interest in this approaching us. It's something that we are currently working on from a sequence point of view, but we only have our insular sort of perspective of what applications we'd like to see in there. So yeah, it's supposed to be a kind of flexible field for multiple applications. That's the idea. So any form of wave data can go in there, or not. But yeah, it'd be great to get more users' input on that. And on that topic, someone had just said it'd be great to process the VAP monitoring on the Siemens transmit, if that isn't already possible. I don't know if anybody's tried to do that.
I think it could be possible. I mean, anything's possible if someone wants to write the code for it.
I think the VOP data does come through the receivers.
I'm not actually sure the format.
Yeah.
If it is something that's stored in the mes.dat file, if it's getting that far, then in principle that's going to get through to Gadgetron.
Yeah, and it's read in by mapvbvd, so it's probably not so far off. It just has a different tag in the MDH header.
So this is it saved as a sync data, or it's another type?
I'm not sure really how it's saved quite. That's something that we've wondered about. So it appears as samples in the, like if you use the measurement data browser, it appears as if it's extra receiver data. But no, it is receiver data. They're ADC data events because they're digitized by the receivers.
Right. So I think it's a separate MDH flag that.
Yes, yeah, so basically whenever the parallel transmit system is transmitting, the receivers are actually connected to some directional couplers in the transmit chain, and those are being digitized during the transmit as a receive event that's automatically inserted by the sequence. So they, in many respects, they're basically just completely ordinary RF receive data. They just have a flag that says VOP.
Yeah. If you have an example data set, maybe we could work through an example and see if we could either check to see if that there is support for it already, or to add support.
Cool. Yeah, we do. We can share. Thank you.
Yeah.
Perfect. Okay, I think this is probably a good moment to wrap up the Q&A. We've done another marathon 4-hour session of Gadgetron. Yeah, thank you everyone for your questions. Keep them coming throughout the week, and we'll try to pick out any particular things. The things that we've mentioned today, if you have more questions and want to contribute, then of course we'll always be extremely receptive and more people wanting to help. And we all brutally ignored someone's question at the start of the day from Nikki Damastani. She was asking, will the PDFs of the talks also be made available? And I think we were trying to upload them to the course, the GitHub course. Is that the idea? Valerie?
Yeah, sorry, my connection is really unstable. Yeah, we will put the PDF on GitHub, and I'm not sure which one is missing. Don't hesitate to tell us things, and we will do that this week. And we put also the video for next week. And I will say, yeah, just 2 words. So next week is a session on MATLAB. So we go back to, let's say, practical work. And so please try to during this week to convert your data and give us feedback, and to install Gadgetron MATLAB within MATLAB. So you need a version higher than 218A, and you will discover so amazing application from Oliver, Aurélien, and Stan, and an explanation from Christopher about the Python or MATLAB interface. I mean the concept, how it's working. So I would like to thank all the speakers, if there's nothing more to add, and for the session today. And we give you, so see you on next week.